Thank you for taking time from your busy evenings to attend League of Women Voters Water and Infrastructure Group. Today, I'd like to introduce Ted Brodeur, a supervising engineer for the LA County Sanitation District. Take it away, Ted.
Good evening, everyone. Thanks for showing an interest in the environment and everything, the waste side of it, because that's what we are. The Sanitation Districts is a unique agency that we're the largest wastewater agency in the country. We handle over 400 million gallons a day of wastewater. To put that in perspective, that's filling the Rose Bowl 60 times a day. It's a lot of water. My background, I'm a civil engineer. I've been doing this been with the districts for 34 years. I have 37 years of civil engineering experience, 17 in design and another 20 in managing construction projects. I'm going to go through two different presentations tonight. One is we're heading up on our 100-year anniversary as an agency. And I'm going to go through our century of accomplishments, which you can see on the screen in front of you. And then I'm going to go into the wastewater side, specifically about how we do what we do and the partnership that we have with you, the residents, and how we can do a better job of taking care of our water. So I'll get to the presentation. The sanitation districts was started in the 20s. If you think back to the 20s, there was a whole lot of development that was just happening. Mulholland had brought water into LA, and everybody was enjoying time and having fun. The city of LA had their own sewer system at the time, and not a whole lot of ways to get rid of the water. So they built an outfall that sent the water out to a pier and dumped raw sewage out into Santa Monica Bay. This outfall that's right here is at the Hyperion water treatment plant over by LAX. During the 20s, when they were out swimming in the water, Hermosa Beach, Santa Monica Bay, they would end up with raw wastewater, literally, fecal matter floating right by you as you were swimming. And they would have all kinds of health impacts because of that. The engineering science for understanding what was happening with oceans and how currents worked wasn't really well developed back then. There wasn't really a need to until they started discharging raw wastewater out into the ocean. It was pretty nasty back in the 20s. So they started figuring out that we're going to have to do something different. And when the sanitation districts was formed in the 20s, we knew that we were going to have to build off of the negative aspects of this and come up with something better. So we chose to find an area that's a better, geographically better. There are no beaches. If you live over here, or if you look over here, this is White's Point is over on this area. This is not next to beaches that hundreds of thousands of people are going to every year. It's pretty remote. And so we decided that we're going to build a treatment plant someplace over in Carson and dig tunnels to get out to an outfall. Trying to get through the. So we took over a farm in Carson and decided to build our facility out, our joint water pollution control plant there. So I'm trying to figure out how to navigate this better. So A.K. Warren was a surveyor really by trade, and the head of public works back for LA County back in the 20s. And as Grace and I were talking earlier, storm drains, when you go and you look at the storm drain system, the storm drains are difficult to understand how that, who owns it or whatever, and figure out who services it, because the ownership was spread out over different cities. Back in the 20s, if you wanted to build a storm drain line and you wanted to get to, say, the San Gabriel River or the LA River, if you're in the middle someplace, you had to get rights to get through that city, and the cities would actually, the mayors would fight each other over rights to get through the cities to get your stormwater to a way to get it to the ocean. And A.K. Warren, the guy was a genius. He said, we got to get past this. And so he came up with a different plan. And he said, what we're going to do is we're going to make a regional sewer system and get past all of the individual cities. We're going to make it so that it's run by districts, which are self-contained, but the districts are self-contained, but inside each district has got a multitude of cities. And that, by doing it that way, they prevented all of the infighting that was going to happen, the political infighting that was going to happen. And so they were going to put the plant in Carson, and then which is over here, and then run a treatment or an outfall that goes out to the ocean outside of White's Point. And I'll show you pictures of those in a little bit. The idea was to have it funded by sales bonds, and which was still a common way to fund public works projects. So the inland cities didn't really like the idea. They fought back. So nobody wanted to pay for it. And so what happens if you don't sell the bonds? What happens? Why can't we do something different? And this is something that we see today. Everybody wants an inexpensive solution to a very complex problem. And the issue is that, as you can see, treatment is expensive. Taking the water to a treatment plant is expensive. It costs money to put sewers in, and it's difficult. People are in a flush and forget mode. They don't really pay attention to what happens after they flush. They just want it gone. And this was one of the first times where we were pushing really hard to come up with a regional solution. So the city, actually LA County and the state, they weren't convinced that Warren's plan was going to work. And so they pushed back, and they hadn't seen any positive, because of the city of LA, they hadn't seen any positive impacts or consequences, I guess, of discharging to the ocean. Because like I said before, Hyperion was just sending water, raw wastewater out into the ocean. So it made it difficult to get people to buy into the plan. So the districts went and hired another firm to actually try to validate the plan. We went with outfalls, which the city of LA did not do. And we pushed them out farther into the ocean so that they would blend more with the wastewater. And so you're going to put it deep on the floor of the ocean, like 300 feet down on the bottom of the ocean, and you're going to allow that to mix with the water. And that whole mixing turbulent action breaks up the particles, and so the microbes can eat the sewage before it gets anywhere and before it makes its way back. So the firm actually went and validated the plan, and then convinced the state and the cities to go along with the plan. So we were formed as a district in 1923 and kept going. The joint disposal plant, and it's now called the Joint Water Pollution Control Plant, was built in Carson in the late 20s. It was finally finished in the late 20s. If you look at the picture, you can see all of the oil derricks in the background. Believe it or not, we're running, as we're building our sewers, even today, we run into a lot of these old wells as we're going, because when they abandoned the wells, they didn't, they never took the wells out, they just put a cap on it. So we're constantly dodging these things, hitting them as we're building new infrastructure. So this is an example of sewer construction that happened back then. You can see we didn't have backhoes. We didn't have the industrial equipment that we do now. These were pipes right here. This is a semi-elliptical, I think a 78-inch semi-elliptical pipe. And these were all cast in place. You put rebar together and formed it and then poured it. And these structures still exist. We were putting tiles, clay tiles on the inside to help prevent corrosion of the concrete, because even then we knew that the concrete can corrode. And these are some of the best looking sewers, best designed sewers ever. For the engineering behind it's very cool, very cool. And this is me being a geeky engineer. In order to get across, we had to go underneath San Pedro and underneath the peninsula. And so we built an 8-foot tunnel. So this here's the chief engineer, and this tells you the kind of guy he was. He was a guy that was going to go out and get dirty. He wasn't a super educated guy that was going to sit in an office and just watch things happen. He actually went out and went with the guys to go into the tunnel. I can tell you that we couldn't build this tunnel today. OSHA, all of the things that we did back then, the ventilation, all of it, we couldn't even begin to get away with it today. And the rules, the safety aspects are much, much higher. So we built a control plant in 1928, finished it, and now we get to start building the infrastructure. The problem is that World War II happened. And so with World War II, it interrupted a lot of the development that, a lot of things got stopped. The influx of people kind of went away. Everybody was moving out of the area or going to war. Industry was coming in to help, to build to help the war effort, I guess, to build the tanks, build the planes, all the rest of it. But the population wasn't growing as fast as a lot of people thought. Unfortunately, as you can see, even today, people think that smog, that all the air pollution problems that we've had were all started with automobiles, and it couldn't be any further from the truth. In the 20s, 30s, and 40s, when we didn't have an active waste disposal mechanism. We had dumps, but most people didn't use dumps. Most people had backyard incinerators, as you can see in the picture, and you would just go and you would throw everything in here. And when I say everything, I mean, wood, paper, your newspaper, if you had apples, oranges, peels, whatever, everything got burned because it would get so hot that it would incinerate virtually everything. And so the amount of stuff that you actually put out the curb to go to the regional dump, like the San Gabriel dump or the Del Amo dump, all of that volume that was going there was actually fairly small compared to what it is today. So they learned fairly quickly that we've got to do something with this. We had, if you look at the pictures of New York City today with the massive wildfire that's happening up in Quebec, this is what it looked like in the 40s and the 50s and the 60s. So it was pretty bad. So the Sanitation Districts Act, which was formed in the 20s to start the agency, got amended. And it took us a long time to get that through. And you'll see why. It was amended in 1949, but nobody, the politics of waste started entering in. So if you can see, there are a lot of people that didn't want us in the waste hauling business because that's where these guys made their money. There's a fine balance between being a waste hauler and a waste disposal, the final recipient of it. And so the agency was fighting tooth and nail to try to build these facilities, the landfills, but we had to go back and forth with Sacramento in order to get the act amended properly. No one would vote for it, and they didn't vote for it because they were being, influenced by the waste haulers. So we finally got them to say, we amended it in 1949 to say, in 51 to say no hauling, and then and tried again, and finally got it passed in 1957. So you can see it took us 8 years to get from when it actually took us 6 years to develop the act and another 8 years to get it passed. In that 8 years, you were still looking at the air pollution problems that we had through, in the area. And, it's staggering to think about how the money aspect of this, polluted our environment. But it's a recurring theme in LA, unfortunately. So we get the act finally passed in 1957, and we start buying landfills. Incinerators were banned, and there were a lot of people that were not happy about that. Specifically, the people that made the incinerators, we just knocked them out of business. And so then, there's always this balance between industry and doing the right thing. These people didn't really care about what was happening to the air. They were just looking at, I need my money for building my incinerators. So in the 60s, we started acquiring or opening landfills. The Puente Hills landfill was called the San Gabriel dump before, was opened in 1957 by somebody else. We purchased it in 71. Palos Verdes, we bought and opened. Spadra landfill over in Pomona, we opened in 57. Shoal Canyon, which is run by the city of Burbank, it was opened in 61. Mission Canyon landfill, there's like a whole political story about that one. That was opened in 1960 and closed in the early 80s, I believe. In Calabasas, which is still open, it was opened in 61. This is what the Palos Verdes landfill looked like. Drive your car in, dump your stuff off, and these are the old trash trucks. Kind of cool. This is the Calabasas landfill. Actually, this is 2021. So for those of you that don't know, there's a huge difference between a landfill and a dump. So back in the 50s, actually up until 1974, when the Clean Water Act was passed, you could dig a hole in the ground and just go dump whatever you wanted to dump on the ground, and nobody really worried about it. Mother Nature was going to take care of everything because that's what Mother Nature did. I have pictures of the Cal Compact landfill, which is over off of the 405. Back in 1952, I have a picture of a guy kicking a full barrel of benzene, 55-gallon drum of benzene, and dumping it out into the ground so it could just hit the ground and percolate into the ground. Because back in the 50s, everybody just assumed that the ground could handle whatever you threw on it. Nobody actually connected groundwater to the stuff percolating through. Everybody thought that all this stuff would just stop in the first few feet, not a big deal. And we now know that it just keeps going, and it'll keep going all the way down. Gravity works, and it'll pull the water down into the groundwater table. The difference between a landfill and a dump is a landfill is hydrogeologically isolated, which if you see these are liner panels that over here that cover a clay, basically a geosynthetic layer, plastic, clay, plastic, that keeps the water from ever getting to the groundwater. Whatever water percolates through the trash ends up being collected and put into a sewer line to go to a treatment plant to get treated. Some of the nastiest water you'll ever see is the leachate that comes from the landfill. But we have sensors and treatment mechanics that are in there to first detect if we have leaks in the liner, and then to go and mitigate those. So there's a whole science now to landfills that is, the district has been on the forefront of since the 70s, when we started, the Clean Water Act took over, and we started upgrading our landfills. It's been an ongoing process. So this is Shoal Canyon, which was opened up. It's closed, or it's still going, but it's going to probably close in 3 to 5 years. This is the Puente Hills landfill in 1971, and this is what it looks like now. These are the gas headers that come off that collect the methane that's coming from the trash that's buried. And I've worked on this landfill for 15 years, and we listen to people talk about how the landfills are ugly, the landfills are terrible places, there's all kinds of rats and vermin. There isn't. We have coyotes, deer, mountain lion, rabbits, hawks, golden eagles. The Puente Hills landfill, there are 4 pairs of breeding pairs of golden eagles. They actually mate for life, and they live up there, and they hunt. Not rats, they hunt ground squirrels and the rabbits and stuff that are eating all of this stuff. If our landfills were so bad, the critters wouldn't be up there. They would run away from it. They wouldn't last. So it's another one of our success stories. So we got the public landfill started in the late 50s and continued on. So here we go in the 60s, and I love these cars. Freeways, people, everything's coming in. So if you remember I don't know if any of you are old enough to remember, but Downey, Lancaster, all of the areas here, after World War II, Downey was a bunch of dairy farms. There were a bunch of Portuguese dairy farmers in Downey. Same with Lakewood. It was a lot of farmland that, because of the Cold War and industry moving into LA and the amount of water that was here for people to use, we started developing like crazy. The problem is we didn't think that problem all the way through. We were bringing people in, but we weren't looking to see where the water we needed to keep the environment going or keep them going, where was that water going to come from? And so the district started looking at, okay, well, how can we be part of that solution? And so we started looking at reclaiming the water. In the past, all of the water in the agency would go all the way down to the joint plant, get advanced primary treatment, which is basically removing most of the floaters and sinkers out of the water and then discharging it to the ocean. But that means all of that water, once it hits the ocean, it's useless, can't use it anymore. So we started saying, okay, maybe there's a better way to reclaim that water and use it upstream, use it to percolate into the groundwater table so that residents can actually use it and then cycle it back out. If you will, the beginnings of toilet to tap. And so we commissioned a couple of studies and went through a couple of iterations of designs, and we built the first reclaimed water plant in 63, the Whittier Narrows Water Reclamation Plant. It's in a floodplain, so you'll see all these structures are high. Most of our plants, this is at ground level. For Whittier Narrows, this had to be above ground because the Whittier Narrows Dam is just down here. And if this floods, if we ever ended up with a flood, it would have to, all the treatment plant process would have to be above that water level. And so this was more of an experiment that we did to prove, like proof of concept. Let's do a treatment plant, divert some of the wastewater that was coming from the Azusa, the San Gabriel Valley, and we're going to divert that over into this treatment plant and prove that you could reclaim water. and it actually was a success. But as you'll see, a lot of people didn't really like the idea, specifically Metropolitan Water District. They were against it because they were planning on selling all the residents more water. And so if we were going to interrupt that plan, then that would take money away from them, and they didn't like it. So that's why they didn't like us building our plant. So we fought through and ended up building WRPs along the San Gabriel River so that we could just redo the Central Basin Aquifer, not the West Basin Aquifer. And so that's where we ended up with. We now have plants. This is the what is that? That is the Los Coyotes plant, the Whittier Narrows, or sorry, Long Beach plant, the Los Coyotes plant, the Whittier Narrows plant, and the San Gabriel or San Jose Creek plant that's here. The idea behind these was not to, we'll go into this in a little bit, but the treatment plant process is really, there's a water portion of it and a solids portion of it. The water portion gets us clean water that we can use to inject back into this. The gray area is the Central Basin Water District, the aquifer that's here. The solids requires a different treatment plant process to deal with it, and I'll get that into another presentation. But the joint plant down in Carson over here has the solid waste, the solids treatment facilities necessary to do it. And by doing it that way, it kept the footprints of the WRPs much smaller. The digesters take up a lot of room in order to be efficient. So this is an overfly of the San Jose Creek water reclamation plant. These are aeration tanks where the microbes are digesting the food and the wastewater, and these are final clarifiers, secondary clarifiers, where the bacteria settles out. I'll go through that process in a little bit. So what ends up happening is by doing that upstream, we can reuse that water. And for the last 30, 40, 50 years now, last 50 years, we've been using our reclaimed water to offset the use of potable water. So if you guys are out and you look at the purple pipe system that's out in the streets, out in the parks, this is the purple pipe water that you're seeing. And you think about all the irrigation that's happening, all of that stuff that happens, this is like a double benefit here. So we use that water in lieu of potable water, and we're spreading it out on the ground for the grass to use and the critters to eat the grass and all the rest of it. But that water's not wasted. You know, a lot of people think that the water's just wasted. It doesn't. Whatever is not used by the grass continues to percolate down into the groundwater, and then we get to pump it back out as water. So these are like sand filters that are cleaning the water to get it back with an intermediate use in between. And another benefit of that is that with all of that green stuff that's there, that's chewing up a lot of carbon dioxide. So that carbon, you know, if we're trying to reduce our carbon footprint, all of this stuff actually benefits that. We got trees, grass, cemeteries, parks, everywhere we can use reclaimed water to offset the potable water use is what we're trying to do, trying to facilitate. So we built our water reclamation plants in the 60s, and we're continuing to upgrade them as we go. Every few years, we increase the quality of the effluent. We change our treatment, tweak our treatment plant processes to create higher quality effluent to meet ever-changing water quality requirements. But it's the engineering behind it is actually pretty good, actually really fantastic. So energy in the 70s, if you guys remember the oil embargo in the 70s, put a big focus on energy. Prior to then, if you wanted to make power, you were running it off of gas turbines. You're basically how you make electricity is you run a steam turbine and it generates electricity by boiling water, but it's expensive and you go through, it's not a very efficient process. So what the districts decided to do was harness the methane that's coming out of our biosolid or out of our digesters at the joint plant and turn that into a biogas. With the biogas, we can, this is a total energy facility, we can, run the steam turbines and generate, it's 20 megawatts. That 20 megawatts is enough power to run all of our plants. We generate enough power at the districts to run all of our plants and have leftover power to put back into the grid. We actually, with all of our facilities, we generate over about 100 megawatts of power a day. There isn't anybody else like that in the country. We're really, really good at this. So that was the wastewater side. This is the landfill side. Joe Edberg had an idea that we could actually harness the methane that was being emitted by the landfills, and we could run a generator from there. And so he went and designed one and made enough power to run a Christmas tree. And again, proof of concept. Hey guys, I know that we can make this thing work. We just got to try. And so he went, built it, and lit up a Christmas tree. Now, that proof of concept is the Puente Hills gas to energy facility. If you ever drive up the 605 and the 60 and you look up at the Puente Hills, you'll see these steam clouds. We have three steam turbines that generate power 24/7 all day, every day. And it's all 100% of that is coming from landfill gas. As the landfills break things down, they generate methane. It's an anaerobic environment inside the landfill. And so they generate methane gas. We have wells and gas headers that suck off that gas, create a vacuum and suck that gas off and run it over into the steam turbines. And so we're taking a terrible, terrible, terrible greenhouse gas. Methane is 100 times worse than carbon dioxide as a greenhouse gas. And we take that methane and turn it into just regular carbon dioxide and energy. So, the mission of the districts is to take what everybody else considers to be a waste product and turn it into something good. And this is yet another example of that. So we used to have the Commerce Refuse to Energy facility, and this is the SURF that's run by the city of Long Beach. These two facilities burn, actually, both facilities were burning waste products. And we would actually take the slag that was left over from the burning to put into cement. Actually, it becomes a part of a cement product. The problem with running these facilities, as we have ever increasing air quality requirements from the Air Resources Board, AQMD and AQMD, and those make it harder and harder and more expensive to meet those guidelines and the requirements. And so because it no longer becomes cost effective, or you're not even penciling out where what you're doing is even at a break-even point. You're losing money and a lot of money trying to get there. And so we closed this down, I believe, in 2016, 2017, because we just could not economically make it work. SURF is running up against that right now. I'm not sure how they're going to, I'm not sure if they're going to be able to stay open. It's just the advanced treatment processes that are required to clean the air are so expensive that it's difficult to make it work. nobody wants to pay for this stuff. So trying to sell the public on, I'm going to increase your weight, your solid waste rates to help keep surf open, just hits deaf ears. It's just one more bill that people don't want to pay. Art Torres was one of the leaders in landfill gas. Was doing a pretty good job of keeping it together. And the 80s, we finalized either the design and or the construction of a number of these renewable energy facilities. So the state was concerned that we were going to run out of landfill space. This is the Puente Hills landfill. And you can see that's a lot of trash. And they wanted to do a better job of managing what was coming into the landfill. And so maybe there was a way to intercept some of this stuff instead of just burying it and saying goodbye. Let's see if we can't divert some of the reusable stuff. So they passed AB 939 in 1989, but it required us to divert 50% of what comes into the landfill by the year 2000. And part of that, we got credits for the green waste. So by segregating the green waste, this is actually, it's a really cool thing. You can make it into mulch, can help make it into mulch, but you can also use this as part of your daily cover. So rather than using just soil, we could put this over the top of a layer of trash, which then kept the birds and the critters that like to go take the trash. It keeps them away, but it also acts, because it's decomposing green waste, it actually acts as a seed, so that the bacteria that's just inherent in the grass just starts feeding or supplying the degrading products down below in the trash with microbes to eat it and convert it into methane. And if you guys have ever mowed a lawn and bagged the grass when you get done, if you stick your hand in 2 or 3 hours later, the middle of the grass is right around 100, 115 degrees. It's pretty hot, hotter than your hand. And it's the reason it's hot is because there's all kinds of microbial action happening there. And this whole green waste product, part of that was to capture that natural, almost fermentation kind of idea and make it work for us instead of against us. And we would get credit for it. We also built material recovery facilities to divert recycled materials. If you ever go to a landfill and you watch that, we have, we call them waste streams. There are different waste streams. You have like just regular refuse that comes in that doesn't have any resale value or any other value other than making methane. That's going to go one place, but people dump all kinds of other stuff. They dump carpets, they dump lumber, they dump, like construction lumber, they dump tires, they dump refrigerators, like appliances, refrigerators, washers, dryers. All of those things can be recycled. There's all kinds of useful materials that are still there. And we're trying to come up with a way to build facilities to allow us to divert that stuff. And so the first one we built was the Puente Hills MRF, and that's over by the Puente Hills landfill is right here. And so what we did is we worked to deal with the city of Whittier and some of the other neighboring cities to divert office waste. So like paper, we would not believe how much paper people go through and just throw, put in that blue recycle bin. Where does that go? It was, well, it's the equivalent of flush and forget. I put it in a box and it left the building. Well, where does that go? Well, prior to the recycle bins, all of that paper would end up in a landfill. And so now we're cutting down trees to make paper and then we're just putting it in a landfill. Paper does not degrade very well. It just doesn't. We've done cores into landfills all over the country. This is not just us. Agencies have done cores into landfills, and you can find readable newspapers that are 70, 80 years old. They just don't, the bacteria can't make its way in between the sheets. And so it just doesn't degrade. And so it doesn't make sense to put that stuff, take up a bunch of volume in a landfill when you're not getting any benefit back from it. And so, we started identifying the waste streams that would be beneficial. And so aluminum, glass, steel, paper, high density polyethylene, HDPE, PVC. There are so many products that people just toss that can be repurposed. And so we built the Puente Hills Materials Recovery Facility, the MRF, to set up these sorting lines to make sure that we could actually do that and do it, make it pencil out. It takes, I think, 4,000 tons a day. The Puente Hills landfill was taking up until the recession, in the late, or the 2011, 2010, 2010, 2011, the beginning of the recession, we were taking 13,000 tons a day and meeting our limit at 11 o'clock in the morning. After the recession, or during the recession, we couldn't hit 7,000 tons a day, leaving it open all day long. We ended up having to close it down on Saturdays because we just couldn't get enough waste. People don't understand that don't put the pieces together, that if you're not buying stuff, you're not throwing stuff away. If you're not buying or building, you're not throwing away. And so a lot of the volume of regular refuse went down, but paper, plastics, a lot of the recyclables did not. And so the MRF was able to keep up and running. These are all sorting lines. I have another presentation that talks about this stuff. But these things, you can see all of this paper that's palletized here. Those are all trees that are being saved. And we're going to push that back. And what was happening before is the Chinese containers would come over filled with products with all kinds of excess packaging on them. And they would come here full of that, and they would buy the paper, just these bales, and take it back to China, reprocess it, and send it back to us. So it was like this circle that's happening, this loop that's happening. But the benefit to that loop is, even though we're going through that, we're saving trees, saving water, we're saving a lot of things by repurposing it. So that puts us into the 2000s, early 2000s. Climate change. This is another one of our problems. We're generating a lot of methane, and the amount of carbon dioxide in the atmosphere keeps going up. Methane, when you dump food into a landfill, as the food breaks down, it generates methane. As much as we want to capture as much of the methane as we can, it's not a very efficient process. So trying to stay, to keep reducing our carbon footprint, the idea was to maybe we can intercept the food waste, the stuff that comes out of restaurants and in food packaging plants. If you're buying tomatoes, you get a bunch of tomatoes end up going to a canning facility, but not a lot of them, or a lot of them can't be used. By the time they get there, they're moldy, they're just not usable. And in the past, it would just go into a container that would go to a landfill, and it would start, breaking down. So what we found is we ran a pilot program that if we just created a slurry out of this stuff, took all that waste and turned it into a slurry, basically put it into a big blender and then feed it into a digester, an anaerobic digester, it'll create a biogas. And that's what this is about. It's making a biogas. that biogas, it's a much better byproduct, a collected byproduct that we can then use to generate green energy. We use it, it's compressed natural gas. We use that to power CNG vehicles. CNG vehicles, although they're not perfect, their carbon footprint is an order of magnitude less than a regular gas vehicle, petroleum gas vehicle. So we're, again, trying to get to a much better environmental position than we were. The cool thing is what's left over, we can turn into compost, where if your compost goes up to the central basin, like a Tulare, the farmland in the middle of the state, and helps. When you put, we're not very efficient organisms. When we eat, we leave so many nutrients behind in the food. And so even when it comes out of us, it's still loaded with nutrients. And to just throw that stuff away, bury it in a landfill and never use it again doesn't make good sense. So we started composting facilities. We have one up in Tulare Lake, where we take the biosolids that come out of the digesters and send them up there. It gets composted, and then the farmers use that compost to put nutrients back into the soil that are being taken away just by growing plants. So it's this constant cycle of reuse that we're trying to encourage and be a big part of. So interesting note is if you ever put compost out in your backyard, like Kellogg's or anything that's composting, and you end up with a tomato plant out of the blue. Tomato plants, the seeds of tomato plants are one of the few things that will make it all the way through all of our treatment plant processes and still be able to work. They are very, very robust plants. The seedlings, they have this gel that's on the top of them that just does not break down until it's in the right environment. Mother Nature being the really smart goddess she is. So we use the biogas that's generated off of that to generate energy. This is our total energy facility again. So we're using the combined gas from the food waste program plus the digested solids, the digested solids process of the wastewater to generate energy. The joint plant, the total energy facility, actually has a cryogenic facility attached next to it, which generates, and this will make sense in a little bit, but it generates pure oxygen. And we use that pure oxygen system to run one of the processes at the joint plant, and it is 70% more efficient than any of our other plants, just because it's on a pure oxygen system and it's free. Running the process is free because it's all energy dependent and we're making our own energy. So it doesn't cost the ratepayers $1 more for us to do this. It's another one of our success stories. And this is the biogas that's turned into CNG. This is our CNG facility by the joint plant. So you can see that we're getting there, but we're almost carbon neutral, but not quite. But we're doing our best to get us there. So that gets us to Lake Mead and our water problem. So the joint plant is the last untapped resource of water. Our problem is that in the upstream plants, we have a pre-treatment process that keeps a lot of the chemicals out. We force the industrial manufacturer, the industrial manufacturers that are up there to treat their water before it gets to us. And by doing so, the water is missing a lot of the bad constituents. When you get down into the South Bay, we don't have the same treatment plant processes to clean the water. So that water ends up coming to the joint plant, and it's there are more salts in it, and that doesn't, you'd have to be a water person to really understand, but you're gonna end up with a lot more magnesium, just regular salts that are in the water that make it unusable for us to just turn it around. Removing the salt is difficult, and can be expensive. The joint plant's kicking out on the order of about 200 million gallons a day, and trying to treat 200 million gallons a day to get the salts out is difficult. We didn't, because we're so far down on the, we're like really literally right next to the ocean now. The number of reusers for that water aren't there in order to fund the treatment plant processes that we would need to change in order to make the clean water that we're doing up in the northern, or in the other parts of the JOS, the joint outfall system. So because we haven't built that, the infrastructure isn't there, no one's there to use the water. So we're in a joint collaborative process with MWD to come up with a way to treat the water and make it, we call it pure water, but we're running it through RO filters to remove the salt. And then by doing that, we can then take that water and push it out, pump it out to different areas for reuse. I could tell you all kinds of story about reuse water, but this plan is to take that water and send it up to the West Coast Basin, the Central, and the San Gabriel Basin. And by putting it up there, MWD will then pump that water into their Weymouth treatment plant and then send that water down to the Dimer plant, which would then feed Orange County. And all of this stuff is basically to try to capture, right now it's a 1 MGD plant, but we're trying to get it to a 100 to 200 MGD reuse plant. The downside to all of this is that when you take the salts out of the reclaimed water, you're going to get pure water on the clean side, but now I've got this concentrated brine that I'm going to have to get rid of. And we're still trying to figure out whether the ocean is going to be able to handle the brine that's coming off of that. We're pretty confident it will, but that part of the reason for doing this test is to look at the ocean and see what the ocean impacts are going to be. And that facility is such a success right now that even Newsom, you can see all the politicians that came down, including Governor Newsom. This is Robert Ferrante. He's our chief engineer. He's a big part of it. This is Rupam Soni. She used to work for us, but now she works for MWD. These are MWD people and county supervisors. So we're doing a really good job there. And that gets us to the end of that part. Any questions?
I have one, which is, you said that at the joint plant in Carson, the water is like extremely salty. Is it because the upstream recycling plants have been using the sewage that goes into Carson as their brine line?
No. So it's not the process that we use in the upstream plants, and we have pre-treatment processes that keep a lot of the salts out. And so the wastewater that's coming to us at the upstream plants doesn't have the same salt concentration in it. When you get into the South Bay, it is there. And we didn't have those processes in place for all, the industrial waste program wasn't really as robust. It didn't need to be as robust in the South